Welcome, or hopefully welcome back to the Reliability Matters podcast, the podcast where we focus on the people, processes, and equipment that ensure reliable circuit assembly and manufacturing performance. For those of you who are counting, this is episode number 171. I'm Mike Conrad, and today we're turning our attention to a cornerstone of modern electronics manufacturing, pick-and-place technology. Joining me is Tim Kang, CEO of Hanwha Tech Wind Automation Americas, with nearly 2 decades of experience in the electronics manufacturing space, starting as a mechanical engineer and now leading one of the top pick-and-place equipment providers. Tim brings a wealth of insight into what it takes to build reliable assemblies. In this episode, we're covering best practices for selecting the most appropriate pick-and-place machine, how to get the most out of your equipment, and the common mistakes that can compromise productivity and long-term reliability. Whether you're a process engineer, a line operator, or anyone involved in the electronics manufacturing space, this conversation is packed with practical advice you can use right away. So speaking of right away, let's get started.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Hi, Tim. Welcome to Reliability Matters. Glad you're here.
Hi, Mike. Thank you for having me on the show. I'm very honored to be the first pick-and-place guest to be on your show.
Yes, I am honored that you are my first subject matter expert on the subject of pick-and-place machines. For some reason, we've danced around all other parts of the manufacturing process, from design to test, and there was one big thing in the middle, when I mean big thing in the middle, that we've failed to cover. So it took 171 episodes to get there, but we're finally here. So I'm glad you're part of that. Let's begin with Hanwha. Who is Hanwha? What is its background, and when did it get into the pick-and-place equipment business?
Well, Hanwha is the Hanwha Group is an $80 billion company based out of Korea. We have a wide range of B2B businesses ranging from the aerospace to defense to finance-related businesses. Our business in pick-and-place started about 35 years ago. We started off as part of the Samsung Group, and the SMT division started out initially to support some of the manufacturing within Samsung Electronics. In 2015, the Hanwha Group purchased our division from the Samsung Group, and we've been known as Hanwha Precision Machinery since then. We've recently undergone a branding change to Hanwha Semitech, and for 35 years, we've really maintained our technology and dedication to the electronics manufacturing industry and developing our expertise.
Yeah, it's interesting because in the world of pick-and-place machines, I think pretty much every player, or at least every major player, is part of a much bigger corporation. Juki is known from sewing machines to pick-and-place machines. Panasonic, of course, consumer electronics and control systems, and so many other things. They all seem to come from mega companies, and I like the premise of they kind of built something for their own production and then decided that the world should see it. So that's a cool journey. Let's begin with machine selection that includes the strategy of choosing the right machine and the fit. When manufacturers are evaluating a pick-and-place machine, what are the top few priorities or factors that they should prioritize to ensure reliability, both from an equipment standpoint and a final product standpoint, down the line?
I think one of the most important things that manufacturers should be looking for when they're looking to evaluate a pick-and-place machine is the maintainability of that machine. I think pick-and-place technology has matured to an extent where when you look at all the manufacturers out there, the difference is not as big as it was in the past. So most of the manufacturers are able to support most of the requirements that most electronics manufacturers have. The difference, I think, is looking ahead at how much maintenance you need, how easy it is to maintain, what are the costs involved in maintaining the machines. And when you look at the different types of pick and place machines out there are a lot of high speed modular pick and place machines that take up really a small amount of space in your factory floor. But at the same time, there's no free lunch in engineering. If you have high performance in a small line space, it's a lot more difficult to maintain. So there are trade-offs in any kind of decisions that you make in terms of equipment selection. So I think it's important to look ahead to what your maintenance costs are and how difficult or easy it is to maintain the machine. The other aspect that manufacturers should also look at is the availability, the frequency, and the cost of software updates. Because pick and place machine is not the only piece of equipment that you have in the line. It needs to interface with other equipment as well as your manufacturing management systems and your line programming. So if the lack of software updates prevents you from doing interfaces with other equipment in the future, that it's a potentially big problem you might face. And also looking ahead at what costs are involved in software updates in the future. That's something that manufacturers should look at also.
Yeah, I would think software updates are really important because we've been talking for about 4.5 minutes now, and I'm assuming that the industry's changed since we started talking already. So, you have to design a machine for today's components, but by the time you finish the design and ship it across an ocean, things have changed, right? So customers are probably more on pick-and-place machines than maybe any other product in the assembly space, more reliant on updates and things like that for newer components and things like that. And it does seem to me not just that components and circuit assemblies have miniaturized, but the footprint of these machines, pick and place machines, has largely miniaturized as well. And was your point, just to make sure I understood it correctly, that part of the trade-off between compact footprint and maintenance is it more complicated when the machines are small versus long, short versus long? Was that the point? Did I understand that correctly?
Yeah, absolutely. There's much less space for the technician to go ahead and change out a head or change out a part. So there are definitely trade-offs. Having a small footprint on the line is positive in many aspects, but it's from a maintenance standpoint, I think there are more challenges.
Yeah. It's kind of pick your poison. A slightly bigger footprint, which you deal with like one time, or a small footprint, which gives you an advantage on day one, but then a little bit more complex to maintain. And complex usually reverts to more expensive to maintain as well. So yeah, I can see that compromise. How does the product mix, the customer's product mix, high volume versus high to medium volume, high mix, impact the decision-making process and when they're selecting a placement machine?
I think there's absolutely a huge difference depending on the product mix, whether it's high volume or high mix. But also, I think everybody has different standards on what high volume is and what high mix is. So I think there are multiple categories in between that high volume, low mix, and the high mix, low volume that we really have to be careful identifying the requirements, because some customers tell us, they're high mix, low volume, but they also need slightly higher volume on the products as well. And I think you also have to consider the business model of the manufacturer, and not just the volume and the mix, but also the lead times they're promising to the customers. Because if they have an MPI job that's they have to rush and they have to stop a line to actually run that job, it totally affects your operation and flow of the products in the line. So let's imagine I'm trying to get to San Diego Do I need a fast sports car to get me there? It won't help if I'm stuck in traffic. So it's not just the speed of the equipment or the CPH, but the flow rate that you're able to maintain in your manufacturing line. And that flow rate absolutely is determined by the product mix that you have. So I think manufacturers have to develop a feel for the product flow rate and the capacity that they have. So I've worked with customers who have managed to maximize their output with limited capacity because they were able to refuse all the urgent MPI jobs and were able to maintain a constant flow rate in their manufacturing floor. So I think that's a constant balance that manufacturers need to try to achieve product mix, volume, and lead time, and how their equipment selections match their needs.
You mentioned the acronym CPH, component placements per hour or components per hour. This is just a general statement. In many years ago, I think before Hanwha, at least was Hanwha, I remember seeing marketing materials from other companies that talked about X CPH. You can get 120,000 components mounted per hour or something to that effect. And I'm not an expert in the pick and place field. I'm in the cleaning. I'm past your machine. I'm further down the line.
Yeah.
But I do remember hearing chatter about, that's best case. It's like the EPA ratings on cars, miles per gallon rating on cars. They're always, best case scenario. What affects CPH? So say a manufacturer, let's just say Hanwha, for example, says this machine's capable of X CPH. What are the realities of obtaining that stated CPH? What the max capability of the machine under perfect conditions? What are the factors that could influence the actual CPH versus the technically capable CPH?
Sure. There's a lot of factors that go into determining the CPH. First of all is the products, the bill of materials, your PCB size, and the placement coordinates. So depending on the number of parts that you have, how many feeder slots are you going to utilize? So if you have a lot of feeder slots available and are able to position them in the optimal configuration, and we have pick and place heads that are able to pick up parts simultaneously from the feeder slots for the piano type heads. So being able to pick up parts simultaneously and place them with by moving the minimal distance and at maximum speeds, that will actually improve the CPH. So if you have, for example, a small board with the small number of different parts, that would really help boost the CPH. But in reverse, if you have a very difficult product with lots of different types of parts that require feeder changes during production, that will really have an effect on the CPH of the pick and place machine.
So if I had a machine, what's an average number of feeders on an average machine?
We have I think an good average would be about 80.
80. So if I had a board with 120 different components, typically would I get a second machine and run them in line, or would I do a changeover, partially build a board, change feeders, and then complete the rest of the board? Or what typically is the strategy for exceeding the number of components than a single machine would have the capability to handle as far as a feeder aspect is concerned?
Yeah, that's a good question. There's many ways of doing it. We can add a second machine so that we can add more feeders, and part of that board will be populated on the second machine. That's one alternative that would help with from the standpoint of throughput. But at the same time, it's an additional investment. So what we can also do is have a separate docking cart with the different types of feeders. And if we just swap out the docking cart when there's a need for a feeder change, we can do the changeover in 3 to 5 minutes.
Okay.
So that will be a pretty quick changeover. So that's another example of how your product mix, your product types, and your volume will affect whether to buy a second machine or just to switch out the docking carts with the feeders.
So the docking cart was preloaded with all the feeders
Exactly.
necessary. So you pull the entire cart out, put in a whole
Yeah.
new cart, and
Okay.
hit resume or something to that effect.
Yes, absolutely. Yeah.
Can you walk me through how your company supports customers in matching the right platform? Obviously, you have more than one model, I would assume. Whether it's a bigger machine, a smaller machine, a machine with more feeders, less feeders, whatever the case may be.
Hello.
How do you go about helping a customer guide them into choosing the most appropriate machine for their presented needs? What types of questions do you ask them? Things like that.
Well, we run a lot of simulations for our customers who have needs for production pick and place equipment. So we'll get as much information on the types of products that they need to run, and also the volume that they anticipate for those products. And it wouldn't be just a sample of one or two products, but ideally we try to get the entire product of families that they would potentially like to run on that pick and place line. And we will run our simulation to see what are realistic numbers that they can achieve in terms of weekly production volume, monthly volume, and yearly volume. So, and also we work with them based on the budget that they have, so that we can try to find a solution that can match the production number while minimizing the equipment needed to meet their needs.
If I was an OEM and had, I'm starting a new line, I have a new product, say I'm building cellular phones, and I'm going to build 1 million of them in a year, and there's not a whole lot of change once the production starts. Would you recommend a specific type of machine more suitable for that versus if I was a contract manufacturer saying yes to every job that comes down down from an RFQ, where I have maybe higher mix, maybe shorter runs, things like that? Are there different types of products that are more suitable for an OEM with a consistent production versus a CM with kind of a high mix, medium volume?
Absolutely. For your first example, if you're running higher volume on a lower mix of products, we would recommend our HM line, which is our high-speed modular pick and place machine, so that we can minimize the line space required and really maximize the production volume.
What does
And
HM stand for?
it's a Hanwha mounter. Hanwha
Okay.
high-speed
Okay,
mounter.
it's an internal, more of an internal
Yeah.
designation. Okay.
Yeah. So, and we would have all the lines with the same standard configuration, so that there wouldn't be, minimal need for new programming, or so that we can run the same products on the same lines and they would be able to maximize production. For a contract manufacturer, we would suggest, different lines that have more flexibility to handle different types of products, because you don't know what's the maximum board size that your potential customers would come to you with, or what new parts that you might have to work with. So we try to add more flexibility to the line so that they would be ready in case they have future projects coming on.
With all this talk of advanced packaging, and I'm thinking specifically of ultra high density interconnects and super miniaturized components that these old eyes can't even see, without the aid of super strong glasses. Does that influence the type of machine, or can any of not just your company, but in general, the portfolio of products from Hanwha and others, can they generally handle all the modern components, or do you need to know what type of components are going to be mounted prior to recommending a specific type of machine?
I think most pick and place manufacturers can cover the majority of products that are in the market now. But when we're talking about smaller components or even larger BGA components that are coming out into the market, and we're also seeing larger and heavier boards coming into the market as well. So those do require a special type of pick and place machine. So we do a lot of customization for our customers as well, who have those unique special requirements. And I think we're going to see more of that in the future as well.
Interesting. Are there specific industries that tend to be better suited with a specific model or a type of model? For example, does the auto industry primarily gravitate toward specific features where other, maybe SpaceX or something, would go with a different set of features?
Well, I think we're seeing more and more customers asking for, especially in the aerospace and defense and automotive industries, asking for the same features with regards to traceability, quality, parts verification. So we do have functions where we do electronic verifications of components as well. And with some of the smaller parts, it's really, as you mentioned, it's really hard to even see them. So we have added new sensors to make sure they're picked up correctly. They have the right part size and thickness before they're placed on the board.
Yeah, it makes a lot of sense to do that while you're placing the components as opposed to, SPI well, not, that wouldn't be SPI, but AOI. AOI is like, it's almost you can prevent an escape with AOI, but you can't prevent, the wrong placement and the reflow of that wrongly placed part with AOI. So it makes a lot of sense to have as much of that technology in the pick and place machine. Do you rely on any degree of AI for that stuff?
Um, well, for AI, actually, in terms of placement accuracy, we've developed a lot of interfaces with the SPI and the AOI machine.
Mm-hmm.
So we've had instances where we've installed SPI. We interface with a lot of SPI manufacturers out there. So we get that information and we feed forward it to our pick and place machine, so that it's not our placement coordinates are based out of the results from the SPI. And we also
Interesting. So if a print is a fraction off, not enough to create a defect, but just if it's a fraction off, does that mean that the SPI will send that information forward and your machine will marginally skew that placement so that it's right on the solder paste rather than hanging off the edge of the solder paste over the pad?
Yes, exactly.
Interesting. Yeah, that makes a lot of sense. So yeah, that makes a lot of sense. How much, well, from your experience, what are the common mistakes or missteps that potential customers would make when selecting a pick and place machine, maybe for the first time or for a new line?
Well, I think manufacturers often make the mistake of looking for the latest technology, and perhaps sometimes manufacturers have unrealistic expectations on automation as well. I think pick and place technology has matured to a point where new advancements are very often small evolutionary improvements rather than game-changing improvements. I know at the trade shows, a lot of people talk about game-changing technology, and that sounds sexy, but really in our industry nowadays, it's very few and far between. And even if we had game-changing technology, I can tell you it won't be cheap. So.
Right.
Oftentimes, I think most manufacturers don't need the latest technology, and especially in manufacturing, I think what you really need is something that's reliable and will outperform your needs. Like a good pickup truck, for example, and
Right.
making sure that having that the pick and place machine meets all your requirements. That's important. But I think after you get past the requirements, I think you should look out for other aspects like maintainability. reliability, cost, and other aspects rather than what new additional features that the machine has, which you might not use.
Yeah. Yeah, you're right. It's sexy. I used to work on cars when I was a lot younger, and so I'm a bit of a motorhead. And um, it's often been said, probably somewhat correctly, that never buy a first year General Motors product, as an example, because that's the year they release the car, and then they fix all the bugs by the next year. So when you do buy game changing technology, you don't have a history of reliability because it's game changing. That's the new game, new rules, and the rules are still being worked out. There's something satisfying about time proven technology that is still capable of running everything we need to run today. How much emphasis should be placed on future proofing, if there is such a thing? It's hard to use the term future proofing in electronics because the future is an hour away, quite literally. But how much emphasis should a customer place on future proofing when investing in new equipment? And should they, and how would that future proofing be explained? What should future proofing mean relative to picking a pick and place machine?
Well, I think this is again something that is a challenge to find a balance in, because obviously manufacturers, when they purchase a pick and place machine, they want to be able to handle all possible products that might come out in the future as well. We never want to get into a case where you have a board size that your pick and place machine can't handle, or a part that it can't place automatically. But at the same time, I think we have to manage uh, the the product types that the manufacturer wants to engage in, the market space, because we can't have a machine that's a one size fits all that can handle all products at high efficiency. So again, there's a trade-off between your speeds and the volumes and how much flexibility you have in being able to handle different part sizes and boards. So I think depending on the business model, whether it's an OEM or a CM, and the product mix that you have, I think there has to be a good balance and the range of products and part sizes that should be fed into the requirements.
Let's switch over to reliability and optimization, if you would. Once a machine is installed, what are some of the best practices manufacturers should follow to ensure optimal performance and reliability of the machine?
Well, I think the most important aspect after the machine is installed is regular training and taking good care of the machine. Following the recommended maintenance schedule of the machines, and working with the manufacturer as a partner for process improvement suggestions. Because there are so many different functions in the pick and place machine that can help the manufacturer or the operator avoid potential human errors, manufacturing errors, or avoid defects. And these take time to learn. And the line can be easily operated, and we can get a good output without having to learn all these new functions that are already built into the machine. So I'm kind of guilty of that fact as well. For my new technology, cell phones, or new features in my car, I don't necessarily learn everything. I just need to learn the basic functions that I need. But I think in terms of manufacturing, all these new functions that we've added can really help prevent defects and help you with efficiency. And there are functions that alert you when when parts are becoming empty in the reel. All these new functions that can help efficiency. I think regular training to learn more about improving the operation of the machine is critical to how much profitability that can be derived from the line itself.
You talk about you've been guilty of that. Reminds me, a couple of months ago, my mother, who's 86, needed to move her car. She goes back and forth between Montana and Arizona. She avoids the extreme seasonal conditions of each state. And I flew to Montana to drive her in her car down to Arizona. And I hadn't driven her car before, so I asked her before we got in the car, I said, "You have cruise control, right?" And she said, "No, I don't have cruise control." I'm like, "Oh, this is going to be a long drive, 17-hour drive. This is going to be a long drive with my foot on the pedal the whole way." And I wasn't looking forward to it. So we're driving, we get on the freeway, and I look down and I'm like, well, there's a button for cruise control. Not only did she have cruise control, she had adaptive cruise control, which, keeps your foot off the brake, right? It automatically adjusts the speed. And I'm like, she didn't even know she had it, to your point. So, that was a huge relief in my case. What role does machine software and programming play in ensuring proper component placement and minimizing defects like tombstoning or skewing or polarity, whatever the usual suspect defects are?
Well, I mentioned the interface between the SPI and the pick and place machine to kind of change the placement coordinates based on the results of the SPI machine. We also have the interface with the AOI that comes after the pick and place. So if there are any other sources of error that go into the placement and we detect it at the AOI stage, we can feed back that data to the pick and place machine to adjust the placement accuracy so that after the first run, accuracies will be improved on the following placements. And as for the role of AI, I think we're seeing more and more enhancements on the monitoring the defects, the calibration, and when the machine needs to be maintained. So we're adding more and more capability into the machine to tell us when things have changed from the norm. So if, for example, the linear motors are requiring more currents to run the same motions, or if there are some difference in the vacuum release times from the solenoid valves, I think we can use those data to tell
something wrong at that point. Something's building.
Yeah. And we don't ever want to be in a situation where it's a sudden line down situation. So we can use those data to kind of get us a scheduled maintenance before the machine truly goes down.
What are some of the strategies you recommend for optimizing cycle time without sacrificing placement accuracy?
Well, I think pick and place machine technology has matured to a point where the speed and the cycle times don't really affect the placement accuracy anymore. In the past, the early days of pick and place, we've had that issue where the speed of the machine kind of affected the placement accuracy. Now we have different product types and different with different levels of accuracy. The pick and place machines are currently about 25 microns to 40 micron placement accuracy range, and changing speeds really doesn't affect that. And then we have the flip chip bonders, die bonders at the 5 micron accuracy level, and speeds drop to about a tenth of the pick and place machines that we're used to. And when we go down to the 1 micron level, it's about goes down to about 1,000 UPH or CPH. So at that level, there's difference in the speed and accuracy, but at the levels of accuracy that we're used to, plus minus 25 microns, it really doesn't affect the placement accuracy. And pick and place software packages nowadays will really help users to optimize the feeder placement for maximizing the cycle times. So we have software that can automatically optimize the best machine setup the best setups for the optimum cycles.
Right. Looking
But
at where each component's going, and the shortest path to pick up and place components without getting in the way of any other process. Is that
yeah, exactly. But now what we're also able to do is run the optimization for a family of products. So if you're looking ahead to the number of product runs that you have to run for a whole week, we can optimize that so that we can see what's the best pool of products to run in which schedules and how to minimize the job conversion times so that you would have minimal feeder changes, for example. So let's say we would have feeder we will be able to run product A and B and C without feeder change and minimize the number of nozzle and feeder changes for the products that really need job conversion.
Oh, that's interesting. So it's more than just optimizing one run. It's looking ahead and optimizing a week's worth of runs or whatever the case may be. That would be particularly advantageous for contract manufacturers where they're not necessarily running boards in the order came in. They could run them in the order that would be most efficient.
Exactly. Yeah.
And from a production standpoint.
Yeah. Yeah.
And let's kind of talk about the common pitfalls in usage of these machines. When I say pitfalls, I mean mistakes people make. What are some of the most preventable mistakes you see manufacturers make when using pick and place machines?
I think one of the biggest mistakes is not being trained properly on the maintenance of the machines. There are some very basic maintenance procedures that can really extend the longevity of the pick and place machines. We've had pick and place machines run production for 15, 20 years. And just doing the basic maintenance, such as adding lubrication to the linear guides, and just changing out the filters from time to time can really have a huge effect on the longevity of the machines. It doesn't show up initially, but I think over the lifetime of the machine, I think that really has a great impact on the profitability for the manufacturer utilizing that machine.
Going back just to our previous subject for a moment, a question just popped in my head about optimization. I remember many years ago, different pick and place companies would boast about different types of heads. There was a turret, and then there were, single head,
Yes.
XY things that would, place the XYZ things that would place components, multiple heads, et cetera. Is that kind of standardized now, or are there certain head designs, if that's the right term, that lead to higher placement or greater accuracy or more optimization?
Well, that's a great question. I think for us, we have developed a different set of bonding heads. We have the turret, the rotary type head for really high speed placement. But these are really small heads with like 16 spindles. So these are really high-speed heads for high volume. But the limitation for these rotary heads is that the part sizes are very limited. It's not able to do large part sizes. So we have a combination of the rotary heads and the linear heads for the larger parts and the more high precision parts. So aside from that rotary head, which we call a high-speed head, we have a multi-function head, which can handle larger parts. We also have a high-precision head, which can handle large parts as well as force control on the Z-axis. Force control meaning that it is
how hard you push it down into the solder paste, basically?
Yeah, exactly. We typically do a range between half a Newton to about 100 Newtons in placement force.
Wow. It's amazing to me. I still cannot comprehend how something can happen so quickly and still with so much precision. And that's a general comment to all pick and place companies. It's like, as a kind of an outsider, as a civilian looking in awe of the technology behind that is how that can go so fast, how it can move. It can pick up a component from a piece of tape, travel a certain amount of distance, come down at what looks like near bullet speed, and then not just place it in the right place, but to go from half a Newton to 100 with some degree of repeatability and accuracy is amazing. I don't know how the engineers, your engineers or any other engineers, can fathom that. That's, to me, that's still, I've been in the electronics assembly industry for 40 years, and everything when I first got in the industry fascinated me. Everything fascinated me. And now I'm just kind of like, yeah, I've seen that before. But I still stop when I go to a show. I still stop at pick and place booths and just marvel. I can't get my head around it. Every other part of the industry I've kind of gotten my head around. I cannot get my head around pick and
No, no.
place. It's an amazing piece of technology. Maybe that's just me, but I'm sure you're still in awe of that too when you see it in action, right?
Yeah, absolutely. As a mechanical engineer, pick and place machines were always fascinating to me. It's been kind of or in the early days of pick and place, there was a race to see who was the fastest, and as the bonding heads got smaller and lighter, the gantries were able to move faster, and we've added new technology or carbon fiber reinforced polymers to really make the gantries lighter. We've had linear motor technology on the X, Y, and Z axis to really, improve the acceleration and the maximum speeds of the gantries. And the linear sensors that we've employed now can really help with the resolution on each of the linear motions. So we've really had huge improvement over the past decade in terms of the level of speed and accuracy that we can really show in our pick and place machines.
Yeah, where it really counts. How often should manufacturers audit or recalibrate their machines to maintain optimal performance and reliability? You talked earlier about maintenance and the importance of maintenance, and so what do you recommend the frequency and the types of things customers should do?
Well, that's a great question. There is for auditing or recalibrating machine from an engineering standpoint, I don't necessarily recommend recalibrating the machine too often. And very oftentimes, you don't actually need to recalibrate the machine until something has changed within the machine. So let's say if you've taken out a head for maintenance, or you've replaced the feeder, or you've moved the machine to a new location, that might necessitate the need for a recalibration of the machine for better accuracy. But if you really haven't done anything to the machine, and you really haven't moved it, you haven't really changed out the heads or any other equipment, then it's not something that is a necessity. So we don't. We work with our customers to provide calibration or audit when we do a courtesy visit when we're in the area, but we don't necessarily tell them that you really have to do this within a certain time period.
Yeah. Let's switch to feeders. I assume, correct me if I'm wrong, Tim, every pick and place equipment manufacturer has a different type of feeder, or, so if I had a Hanwha machine and I would buy a Hanwha feeder, or if I had a Panasonic, I buy a Panasonic feeder. I imagine they're all a little bit proprietary. Do you recommend that customers always purchase feeders that are genuine, company-made parts, or is there a market in third-party feeders that can affect reliability or performance?
That's a great question. There is a third party market for feeders, and that's not something that we recommend, because the reliability of the feeders is really dependent on the manufacturing quality that goes into the feeders itself. So for us, we try to maintain the same level of quality by just sourcing from a single supplier that we have quality control with in Korea. And third-party feeders can work, but there's no guarantee how long it will work.
Sure.
So that's the main potential issue with third-party feeders. And as you mentioned, all manufacturers have different types of feeders, but at the same time, there are also different types of uh, feeder categories. So for the longest time, the industry has used pneumatic feeders, and now we're kind of moving away from that, and now we're using more and more electric feeders.
Hmm.
So there's a lot less maintenance involved in electric feeders, and they don't require as much maintenance or a setup, and the lifetime of the feeders has really been extended compared to the past.
Yeah, interesting. Are feeders subject to maintenance? Factory feeders or third-party feeders, whatever. Do they have to be maintained? And if so, is there a particular maintenance schedule, or are they more plug and play?
They're plug and play. They don't need to be maintained. I think it's important to store the feeders well. Rather than just stacking up and not taking good care of them. And the feeders, they don't have to undergo regular maintenance or calibration unless something has been changed out from the feeder itself, like an electric motor or or SD card with the data. That might result in the feeder needing recalibration. But other than that, there's no regular maintenance that is required for the feeder itself.
In terms of your company's approach and industry trends to those, an approach to industry trends, how has customer feedback, particularly from the North American market, that you're responsible for, Tim,
Yes.
influenced recent innovations?
That's a good question. Our customers in the North American market are mostly high mix, low volume, and they do a lot of MPI projects. And one of the requests that we've had in the past from our customers in the American market is having large feeder spaces, and also the ability to supply a tray feeder uh, with the pick and place equipment. And one of the innovations that came out from those customer requests is our side tray feeder capability that we're the only one currently in the pick and place market to offer. It is a conveyor that comes after the pick and place machine that also can be used as a side tray feeder that goes inside the machine itself. So because it doubles up as a conveyor, it doesn't actually utilize any additional space on the factory floor.
Hmm.
And we get to keep all the feeder slots in the front and the back of the machine. But at the same time, now we have this tray feeder capability. So there's a lot less feeder changeover resulting from this uh, side tray feeder. So that's something that a lot of our customers here are happy about.
Yeah, sounds like it. And finally, Tim, time to get out your crystal ball. And these podcasts last forever. They never get deleted. So we can check 10 years from now to see if you're accurate. Looking ahead, how do you see the pick and place landscape evolving to meet the increasing reliability demands of sectors like automotive, aerospace, medical, electronics, as an example, particularly in the age of miniaturization?
Well, we're definitely seeing more component miniaturization, denser PCB designs with much tighter tolerances and error margins and the safety critical factors. I think a lot of our customers are having high expectations for traceability, quality, and having zero defects. So part of that um, uh, change in the industry landscape is forcing us to look at improvements in our vision systems with high resolution cameras, machine learning for light vision alignment, defect detection, especially for BGAs. Uh, we've we're developing 3D cameras to inspect new BGA products that are coming out, and we're also developing more advanced server control with better placement and accuracy. And Now we're also seeing a move into SIP, system and package mounters, that can handle also chips from wafers along with SMT products as well. So those are things that we're seeing a evolution of technology and a move towards as an industry. And real-time tracking, error prevention, traceability, these are all, I think, topics that will keep us busy over the next decade.
Yeah, something tells me your product designers, engineers can't sleep on the job. There's plenty, like I said before, the industry's changed even more since we started talking. So that'll keep everyone up at night. Tim Kang, thank you for your generosity and sharing your wisdom with me and my audience. I really appreciate you being on the show to talk about the long overdue subject of pick and place machines. I really appreciate your time. And for my audience who would like to get more information on Hanwha, if you're watching this on YouTube, look down here. It says "See More." If you click down there, you'll get information on that company, as well as their URL, so you can go to their website. If you're listening to this on your favorite podcast app, then when it's safe to do so, go to your podcast app and look at the show notes, and that information will be there as well. Tim, thank you so much for your generosity and sharing your wisdom with me and my audience.
Thank you, Mike. I really enjoyed being on the show, and thank you for the opportunity.
No, it's been my pleasure. Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on your favorite podcast app. If you're watching this podcast on the Reliability Matters YouTube channel, be sure to like and subscribe to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every single month. And a very special thanks to the Printed Circuit Engineering Association's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating this show. Thanks for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments or episode suggestions to Mike at mikeconrad.com. Just remember that's Conrad spelled with a K. To learn more about the podcast, visit reliabilitymatterspodcast.com. Once again, thanks for listening or watching. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.